Hello friends, my name is Nitin and today we are going to see the mathematics part first, standard 9, chapter first. The name is sets and we are going to learn about practice set 1.4 in which we are going to solve all the examples with the help of Venn diagram. Now see, we will write down here the name of the chapter, that is sets. Sets means Sanch. Practice set number 1.4. Now I am going to write all the questions here, so it will be convenient for you. So question number first: if number of elements in set A is equal to 15, number of elements in set A union B is equal to 29, number of elements in A subset B is equal to 7, then number of elements in set B is equal to, we have to calculate the number of elements in B. Okay, so what we have to do here, answer. We will solve this example by using the Venn diagram. So first of all, we will draw a set, two sets. Okay, so first of all, we have to write down the numbers present in set A. We will give name A and we will give this set name B. So in first set, we have to write down the elements which are present in it. Suppose if set A contains 15 elements and A intersection B contains 7 elements. Okay, so we have to write here total elements from A. Suppose 1, 2, 3, 4, 5, 6, 7 and 8, 9, 10, 11, 12, 13, 14 and 15. Okay, so the remaining element we have to write here. Total 29 elements are here, so we have to continue. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 and 29. Okay, so we can see here number of elements in set A is equal to 15. So we will count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, total this set A contains 15 elements we have counted. And after that, number of elements in set A union set B. Okay, so total elements should be 29. So we will count also 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Okay, this condition is fulfilled. This condition is fulfilled. And lastly, we have to, the condition is given here. Number of elements in set A intersection set B is equal to 7. So we have to count the intersection. Means that the common elements we will count 1, 2, 3, 4, 5, 6, 7. So this condition also fulfilled. Now then tell the number of elements present in set B. So we have to count the total elements in set B. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 and 21. So the answer is number of elements present in a set B is equal to 21. We have counted the whole numbers which are present in a set B. So we have found 21 elements in set B. So that is why the answer of this question is 21. And this is the Venn diagram with the help of which we have found the answer of this question. So write down, I will give you 1 minute. Now we will move towards next question, that is question number 2. Now see the question number 2, I will write here. In a hostel, there are 125 students. There are 125 students, out of which 80 drink tea, 60 drink coffee, and 20 drink tea and coffee both. Find the number of students who do not drink tea or coffee. See here, the question. What is the question? In a hostel, there are 125 students, out of which 80 students drink tea, and 60 students drink coffee, and 20 students drink tea and coffee both. Find the number of students who do not drink tea or coffee. So, we have to solve this example with the Venn diagram also. Now, we will prepare a Venn diagram. Okay, so this is the set A, whereas this is the set B. Now, in a hostel, there are 125 students, out of which 80 drink tea and 60 drink coffee, and 20 drink tea and coffee both. Find the number of students who do not drink tea or coffee. So, we have to calculate how many students who do not drink tea or coffee. Okay, so the students which are drinking tea as well as coffee, are 20, means that the intersection of A and B contains 20 students. Okay, so we will suppose that 80 students drink tea. Okay, 80. So we can write here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, and 60. The 60 student who drink only tea. Now the intersection means the students who are drinking tea as well as coffee, we will write here. After 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, and 80. Now see, the statement is given here. Out of 125 students, only 80 drinks tea. So in set A, we have taken only the students who are drinking tea. So here total 80 students are coming. We can see here the last number, that is 80. So 80 students are taking coffee only. Okay, now we will write down the 60 students who drink coffee. The set B we have drawn here, which is containing the students, number of students who are drinking coffee only. So 20 students are common. Okay, intersection of A and B. Already we have taken 20 students, out of which out of 60 only we have to write 40 remaining students here in set B. Okay, so 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120. Okay, so we can see the total number of students drinking coffee. Okay, so how many students in this set B who are drinking coffee? See, from 81 to 120, total 40 students. Okay, and after that the A subset B means those students who are drinking coffee as well as tea, these are coming inside this intersection. Uh, that are 20 students. 20 plus 40 is equal to 60. Means that see here total in set A, the students we have taken who drinks tea are 80. Okay, from 1 to 80. And in set B, total student must be 80. Sorry, 60. Suppose from 81 to 120, total 40 students are there. Plus the students who are drinking coffee as well as tea, we have taken those students in intersection. So these 20 students from 61 to 80 we have taken or added in this coffee taking, those students who are drinking coffee. 40 students plus these 20 students is equal to 60 students. Means that we have completed this evaluation also. And 20 students drink tea and coffee both. Okay, so see, these students are in intersection who drinks coffee as well as tea, who are included in set A also and set B also. So this condition is also fulfilled. So now we have to draw the set of a hostel. Okay, so these all students are coming under the set of the students which are living in that hostel. So we can say that universal set, the set of the number of students living in hostel is nothing but the universal set. Okay, it is the universal set. So we will draw here the universal set. This is the universal set. This universal set contains all the number of students who are drinking coffee, who are drinking tea, who are drinking both of them, and who are drinking nothing. Okay, so we have found that 120 students are drinking uh, coffee, sorry, tea or coffee or both of them. Okay, and total students in a hostel are 125, but we have counted only 120 students who are drinking coffee or tea or both of them. So how many remaining students we have to write in a universal set? Only 5 students. So we will write here 121, 122, 123. Okay, you can write these numbers anywhere, wherever you will like. 124 and 125. Okay, so we have found 125 students in this universal set. Which kind of this universal set? The students who are living in the hostel, they may be drinking tea, may be drinking coffee, or may be drinking both. And those students who are not taking both of them. Okay, so 125, uh, 125 students who are living in a hostel are included in this universal set. So last point is find the number of students who do not drink tea or coffee. So we can say that from this diagram only 5 students. Okay, only 5 students who can't take anything between tea and coffee. Okay, that are 121, 125, 123. 121, 122, 123, 124 and 125. Only 5 students who are not taking anything of coffee and tea. Okay, this is the answer. Draw this diagram. I will give you 1 minute. Question number 3. In a competitive exam, in a competitive exam, 50 students passed in English. Students passed in mathematics. Now see, question number 3. In a competitive exam, 50 students passed in English, 60 students passed in mathematics, 40 students passed in both subjects. None of them failed in both the subjects. Find the number of students who passed at least one of the subjects. So we are going to solve this with the help of Venn diagram. So a competitive exam, 50 students passed in English. Okay. So we will create a Venn diagram. We have drawn two sets here. For set this set we will give a name A, and for this set we will give the name B. A set is containing the total students who are passed in English, and set B is containing the total students passed in mathematics. And intersection of these two sets containing the students who are passed in both subjects. Okay, so we have to write down the students who are passed in English. So we will write here 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now remaining students who are passing in both subjects, we will write down that in intersection. So 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay. Now we have to write the 60 number of 60 students in set B who are passed in mathematics. Okay. So 51, 52, 53, 54, 55, 56, 57, 58, 59 and 60. Okay, now see the total students who are passed in subject mathematics are up to 70. We have to write here 70, up to 70. Okay, 61, 62, 63, 64, 65, 66, 67, 68, 69 and 70. Okay, total we can say 60 students are there in a set B. Okay, so we will examine or we will confirm the students of each category. Suppose in a competitive exam 50 students passed in English. So set A is the set of students who are passed in English. So we can say from 1 to 50. Total 50 students are there in a set A who are passed in a English subject. Okay. Now we have to see this condition is fulfilled. Okay, this condition is fulfilled. Now we will see the next condition. 60 students passed in mathematics. Now we will count total 60 students are there or not. Okay. We will count 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59 and 60. Okay, total 60 students are there in a set B who are passed in mathematics. This condition also we have checked. Now the next condition, 40 students passed in both subjects. So the intersection area must contain 40 students. So we will count the students who are present in intersection. They must be 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So this condition means that 40 students passed in both subjects. This condition is also we have checked and which is correct. Now none of them fail in both the subjects. Okay, none of them is failed in both subjects. Find the number of students who passed at least in one of the subjects. So we have to write down the number of students who are passed in one of the subject, at least minimum one subject in which the students must be passed. Okay, so what we will say here, we have to what we have to do this see these students which are present in set A who are passed in English, they are passed in at least maybe in both subjects or maybe at least in one subject. This type of students are 50 students. Okay, so set A contains set A contains total 50 students. Okay, set B contains total 40 students. Okay, oh sorry, 60 students. Means that the total students who are passed in at least one subjects are 0, 110 students. Means that we have calculated A union B. A union B is equal to 110 students. Okay, who are passed at least. The word is at least here, means that at least in one subject. Maybe that student passing in both subjects, but here is written at least in one subject. So the students who are passed in both subjects, they are also coming in this uh, answer. Means that the intersection area also coming in it. So whole set A as well as whole set B containing all the students are coming in the students who are passed in one subject. Okay, nobody is failed. That's why we do not have to draw the universal set here. So our answer is 110 students. So draw the diagram and write down the answer, which is 110 students. Okay, I will give you 1 minute. Now see the fourth question, number 4. The question is very big, of near about 6 lines. So I will not write question here. It will take lots of space on our whiteboard. So I will write it in a very short way. A survey was conducted to know the hobby of 220 students of class X. Now we will write the first condition. Hobby survey of class ninth students that are equal to 220 students. Okay. Survey of 220 students is carried out who are in learning in ninth class, out of which 130 students inform about their hobby as a rock climbing. Climbing hobby. Rock climbing hobby. How many students having the rock climbing hobby? 130 students. Okay, 130 students having the hobby of rock climbing. And 180 students inform about their hobby as sky watching. Sky watching. Sky watching hobby. How many students are there in this set? 180 students. Okay, 180 students. Now, there are 110 students who follow both the hobbies. Following both the hobbies. Following both the hobbies is equal to 110. Okay, so this question can't be solved by Venn diagram, because now see this question number 4. We will write this question in a short. Uh, there is a survey which is regarding of hobbies of student ninth class. The number of student is 222, which is our universal set. The 222 number is the number of elements in universal set. Okay. Now, rock climbing hobby. The students having rock climbing hobby. The 130 students are there, which is called as a set A. The number of elements present in set A is equal to 130. Okay. Now, we will assume that sky watching hobby. The students having a hobby of sky watching, that type of students are 180, which is a number of elements in set B. We can say number of elements in set B. The set B representing the students who having the hobby of sky watching. Okay. Now last one is the following both the hobbies. The students who are following both hobbies means that sky watching as well as rock climbing. Okay, these type of students are 110 students. Okay, means that A intersection B, number of elements in A intersection B is equal to 110. Now see what we have to calculate. What we have to calculate. Then how many students do not have any of the two hobbies? Okay. Now next, how many of them follow the hobby of rock climbing only? How many students follow the hobby of sky watching only? Okay, the student who follow only one hobby, we have to calculate in both of these sets. Okay. Now we have to calculate the number of students who are having only rock climbing hobby. Okay, so what we have to do, uh, we have to calculate only the hobby of rock climbing. So what we have to do, we just have to remove the students from set A, uh, those students who having both of hobbies. Okay, we just have to count only one or single hobby, that is rock climbing hobby. Okay, those students who are having only one or single hobby, that is rock climbing hobby. So what we have to do, we have to minus uh, A intersection B from set A. So we will write here number of elements from set A minus the number of elements in set A intersection set B. Okay. Now see, we can place values here. So number of elements in set A, how many elements are there? 130, 130. Okay. Minus how many elements are there in A intersection B? There are 110. Common hobby. Okay, 110 students having common hobby, both of the hobbies. Okay, so what will be the answer? 20 students. 20 students. 20 students having the only one hobby or single hobby of rock climbing. This is the answer. Now next, same as this, we have to calculate the number of students who are having only sky watching hobby. Okay, only the hobby of sky watching. Okay, now we have to calculate the students who are having only one or single hobby, that is sky watching. Okay, so the set of students having sky watching hobby is set B. Okay, and the number of elements in set B is equal to 180. Okay, so we have to write here number of elements in set B minus, so we have to subtract the total number of students having the sky watching hobby minus the intersection of A intersection B, means that the common uh, hobby, the students having common hobby, we have to subtract from set B, as same as this. Okay, so we can write here number of elements set A intersection set B. We have to subtract this. Now, tell me how many students having the sky watching hobby? 180 students. Okay, 180 students minus uh, the students who are having both of the hobbies are 110 students. Okay, 110 students. When we will do this subtraction, how many students we will find? 70 students. Okay, 70 students who are having the hobby of sky watching. Only 70 students having single hobby of sky watching. Okay, so this is the answer of second last question. Now, then how many students do not have any of the two hobbies? Okay, uh, now we have to calculate the number of students who haven't any hobby from two hobbies, that is that are rock climbing and second one is sky watching. Okay, so what we have to do? Tell me what we have to do. Now, for that we have to do that we have to calculate A union B. A union B हमें निकालना पड़ेगा. ओके, A union B, number of elements from set A union B, and after that we have to subtract it from number of elements from set U. Means that we have to subtract the students who are having both hobbies, and then we have to subtract it from universal set, that is hobby survey of class 9 students. Okay, total students who are coming in the survey, that number is 220. Okay, so how can we do this subtraction? Now A union B. A union B means what? The total elements we have to count in a set A as well as in a set B. Okay, so in set A, how many students are there? Now see, number of elements in set, universal set, minus. Now we have to take the number of elements just like this. The students who are having only the rock climbing hobby is 20, plus the student following both hobbies is 110, and the students who are following the hobby of sky watching, that is 70. Okay, so we will place the values just like universal set contains 220 elements, minus 110 plus 20, 130, 130 plus 70, 200. Okay, so here is 200. When we solve this bracket, we will get 200. So now we have to minus 200 from 220. Okay, total number of elements from universal set. We have to subtract 200 from total number of elements present in universal set. So is equal to 20. 20 students. 20 students don't have any hobby. Write down. Okay. What is the how many students do not have any of the two hobbies? This is the answer. Okay, this is the answer. 20 students don't have any hobby. Then, how many of them follow the hobby of rock climbing only? Only the rock climbing hobby having students are 20 students. Okay, and next, how many students follow the hobby of sky watching only? Okay, so that also we have calculated here. Only the hobby of sky watching, uh, only in that set, only 70 students are coming. So write down this answer. I will give you 1 minute. Now we will see the last question of this practice set 1.4. That is question number 5. Observe the given. Observe. Observe the given Venn diagram and write the following sets. Okay. So here one diagram is given. See, here we can see three sets are given. This one is the universal set, this one is the set A, and this one is the set B. Okay, so we will write down the elements of each set: x, y, z, m, n. I will write here just like this, y. Okay, m, n, p, q, r, here s and t. Okay, these are the elements of this set A, B, and the universal set. Now, what examples are given here? See, what we have to write: set A. How can write? How can we write the set A? See, we have to write all the elements from set A. Okay, x, y, z, m, n, like this. Okay, all the elements coming under the set A. So we can write here set A is equal to, in curly bracket, x, y, z, z, m, and n. Okay, these elements will come in set A. Now next, set B. Second, set B. So how can we write the set B? We have to write down the all elements present in a set B. Okay, which are the elements? Set B is equal to, in curly bracket, m, n, p, q, and r. Okay, so we have to write common elements also. Okay, so next, third, 1, 2, 3. Third example is A union B. We have to write A union B. How can we write A union B? While writing A union B, we have to take all the elements present in set A, present in set B, as well as common elements. Okay, all these elements we have to write one time. Okay, so set A union set B is equal to, in curly bracket, x, y, z, m, n, p, q, and r. Last one is r. Okay, so all these elements are coming under A union B, set A union set B. Okay, so next one is example number 4, universal set. We will write here the next example, example 4, that is universal set. How can we write the universal set? See here, universal set. This is universal set, means that this rectangle containing all the elements we have to write here. So universal set is equal to x, y, z, m, n, p, q, r, s, and t. Okay, all these elements are coming under universal set. Okay, universal set is very big. Okay, so now fifth example, we have to write a dash. A dash. So how we can write a dash? A dash means the elements which are coming outside of the A set A. Okay, outside. Which elements are outside of the set A? That are P, Q, R, S, T. P is not coming inside set A. Q is not coming inside the set A. R is not coming inside the set A. S is not coming inside the set A. And T also not coming inside the set A. Okay, all these elements we have to write here. A dash. A dash means what? The elements which are not coming inside set A. Okay, so what are the elements? P, Q, sorry, small q, Q, R, S, and T. Okay, these elements are coming in A dash. Okay, now next, sixth question or example, we have to write down B dash. But we have to write down B dash. So answer will be B dash is equal to, in curly bracket, the elements which are outside of the set B. Okay, now which are the elements? X, Y, Z, S and T. All these elements are outside of the set B and called as B dash. Okay, and last example is 7. A union B dash. A union B dash means that we have to write the elements which are not coming in both the sets A and B. So what are the elements? Which elements are not coming inside A as well as in B? So we can write A union B dash. A union B dash is equal to, in curly bracket, S and T. Okay, this is the end of this practice set 1.4 from page number 16, first chapter 6. Okay, we have completed set practice set number 1.4 from the chapter 6. Okay, and with this we have completed all the practice sets, and further this we are going to solve problem set 1 in next video. So that thanks for watching this video. You have to write down all these answers. I will give you 1 minute, and for such type of videos, informative videos, please like our or subscribe our channel, like the videos, and share it with your friends who are in a 9th standard. Okay, thank you.